Hi everyone, welcome to Math Moment with Mr. Dustin. I'm Mr. Dustin. So today we're going to be discussing probability. Now this is a concept that is generally introduced in middle school and again reinforced in high school. And so this could be a great preview or review for anyone older or younger. And then at the end of this video, there will be a formative assessment and the link is in the description. At the end of the formative assessment, there is a code that you can enter into Beanstack for a virtual visitor badge. So I encourage you to take the formative assessment to earn that badge. So yeah, enjoy the video. All right, so today we're going to be discussing probability. Now, probability is the likelihood of an event happening or not happening. And this ranges from 0 to 1 or 0% to 100%, however you'd like to look at that. And so we determine its probability based on fractions a lot of the time. And so let's say I want to flip a coin. Well, I know that there are only two outcomes when flipping a coin. I can land on heads or I can land on tails. And so the probability of landing on heads, I could say, is 1 out of 2. And then I could say the same thing about tails too, it would be 1 out of 2. And so what this means is the 1 represents the chance of such and such an event happening, and then the 2 represents the amount of outcomes there are. So in the case of the coin, there are only 2 outcomes, and then there's a chance of one of the outcomes happening, if that makes sense. And so let's look at an example here. This is a spinner. There's no actual spinny thing on it, but this would be a spinner. And so you notice we have 4 colors. There's red, yellow, blue, and green. And there are only 8 slices on it, if you will. So you'll notice there's 1 for red, 2 for yellow, 2 for blue, and 3 for green. And so what we're going to do is we're going to calculate some probabilities. And so let's say, what is the probability of landing on green? Well, the first thing you want to do is you want to find out how many green slices there are. So there are 1, 2, 3 slices of green. Well, how many slices total are there? Well, there are 8. So your probability of landing on green is 3 out of 8. Just like that. And you'll notice 3 is the amount of green there are, and then 8 is the total. So let's try that again with blue though. What is the probability of landing on blue? Well, we have 2 blue slices and we know there are still 8. So the probability of landing on blue is 2 out of 8. Now, you'll notice this fraction can be reduced, which if you want to reduce it, you definitely can. It won't change anything about the probability. I could reduce this to 1 out of 4, and that would be acceptable as well. But anyone will be able to make sense of the 2 out of 8 if you prefer to leave it there. I think for probability, this makes a lot more sense than this does. So it's up to you, personal preference on what you'd like to do for that. But I just want to let you know this is available for both. Like you can do this either way. What is the probability of landing on red? Well, we have 1 red slice and there are again 8. So the probability is 1 out of 8. And then what is the probability of not landing on yellow? Now, this is a little tricky because we don't know that exactly. We know that the probability of landing on yellow is 2 out of 8, but what about not yellow? Well, let's count the ones that are not yellow. We have 1, 2, 3, 4, 5, 6 that are not yellow. So what that indicates to us is that the probability of not landing on yellow is 6 out of 8. Now, let's take a moment and observe that the probability of landing on yellow is 2 out of 8. Now, what is the connection between the 2 out of 8 and the 6 out of 8? Well, if I were to add these together, 2 out of 8 plus 6 out of 8 equals 8 out of 8, which is 1 or 100%. This is an important concept because you can take this property here and apply it to any of these. So I could say, what is the probability of not landing on red? Well, now I have to do 8 out of 8 minus 1 out of 8, and that gets me 7 out of 8. So what we can conclude from this is that the probability of landing on something plus the probability of not landing on the same thing equals 1. It is 100%. Something will happen. That's what that means. And we'll go over that with some other examples later. And so what is the probability of landing on red or yellow? Now this one, we could take either of them. So how many red is there? Well, there's 1. And then how many yellow? 1, 2. So 1 plus 2 is 3. So we're going to say probability of landing on red or yellow is 3 out of 8. And so when you have one or the other, you get to add their two probabilities together because both of those are acceptable outcomes for you. And so it would be the same if you were to say neither red or yellow. You would be able to add the green and the blue because those are neither red or yellow. So here we're going into that a little more. Probability of A or B. Now A and B are different events basically. So this tells us the probability of A is 2 out of 5, and the probability of B is 1 out of 5. And so to find the probability of A or B, we're going to add the probability of A and the probability of B, and that is going to be 2/5 plus 1/5, 1 out of 5, 2 out of 5, and that gets us 3 out of 5. So this is where it comes in really handy to know how to add fractions. So that is adding probabilities together, and this is really A or B. That's what you're looking for, the word or. That'll indicate to you that you have to add them together. So we're going to go into a break now, and we'll come back with some more examples of probability, and we'll wrap it all up and identify the important aspects of this lesson. So enjoy the break. All right, so for the break today, I decided to watch a movie, or at least get a movie for me to watch. And so what I've done is I've taken all of the Star Wars movies and I've collected them, and I'm going to decide using probability which one I would like to watch. So we can see that I have 9 movies here, and I've organized them into their respective trilogies. So we have like the first 3, the second 3, and the third 3. And so what I'm going to do is I'm going to put them in this bag, and we're going to figure out the chances of picking each movie as well as pick the movie. So I'm going to mix these up a little in the bag. All right, now I have no idea what order these movies are in the bag, and we're going to choose one from the bag. And so first I'm going to go over some probabilities. So let's say the chances of me choosing the third movie are 1 out of 9, right? The fraction would be 1 over 9. Well, the chances of me picking one of the first 3 movies would be 3 out of 9, right? Because there are 3 movies that I have to choose from, and then there are 9 total. So let's pick one to watch. I got episode 2. So this is one of the first 3 movies. This is the second one. So the chances of me picking this particular film were 1 out of 9. So I'm going to set this aside. Now, let's see. Now my chances of picking the third movie are 1 out of 8, as there are only 8 of them remaining in the bag here. So I'm going to try again here. Let's see. This time I got number 7. So I am going to set this aside. We'll try one more time. I want to see if I can get number 3. But my chances of getting number 3 are, again, well, now they're greater. They're 1 out of 7 since I've set 2 of them aside. So, well, there's number 9. So basically what this is meant to illustrate is that your probability changes when you remove stuff from a bag like this. If you change the total amount of items that are here, then the chance of picking a certain item that's still in here gets greater, and the denominator of your fraction is what changes when you do this. So I just figured it'd be kind of fun, so I guess I'll watch episode 2 this weekend and then we'll go from there. And so I thought it would be kind of fun just to go over a collection like this and see what kind of things probability does for you. It's interesting to kind of figure out, if I choose something at random, what are my chances of actually choosing the thing I want? I wanted number 3. Well, here's number 3, but I obviously didn't pick it, and it was very unlikely that I would have picked number 3. It had the same chances of any of the other ones of being picked. So that's all I have for the break today. We'll continue with some more examples of probability. Hi everyone, welcome back. I hope you enjoyed the break. So let's do some more examples of probability. So we're going to be using dice. This is a normal 6-sided die. So I will write here 6-sided. And what we're going to do is we're going to go over some probabilities involving the 6-sided die. So let's say I decide to roll this. Well, what is the probability of rolling a 1? Well, there's only one side that has 1 on it. So the probability is going to be 1 out of 6. That equals probability of rolling a 1. Well, what if I want to roll an even number? I don't care which even number it is, but I want an even number. Well, this is like saying the probability of a 2 or a 4 or a 6. So what does that mean? Well, we have to add the probability of 2 plus the probability of 4 plus the probability of a 6. And that is going to get us 3 out of 6, because each of those is 1 out of 6. So, and one final one, how about the probability of not a 5? So, let's see, probability of not a 5. Well, that is going to get us 5 out of 6, because as we know, a 5 is only one side of the die, and there are 5 other sides. So if we get any of those 5 other sides, that will satisfy the condition here. So let's look at a little more complicated example. This is a sum of 2 dice chart, and what it tells us is the number that each roll adds to. So for example, if I roll a 1 and then a 1, the two of them add to be 2. A 1 and a 2 add to be 3, etc., etc. And so what we're going to do is we're going to calculate some probabilities of how likely it is to get these numbers when you add the 2 dice together. So this is how we get the total. We're going to take the probability of 1 and then the probability of another and multiply them. And so what we'll do is we'll say, what's the probability of rolling a 1 on the first? So P of rolling a 1 on first is 1 out of 6. And then what is the probability of rolling a 1 on second? Well, that is going to be 1 out of 6. So now what we're going to do is we're going to say the probability of rolling 1 and then 1 again is going to be 1 out of 6 times 1 out of 6. So we multiply these two probabilities together, and that gets us 1 out of 36. And notice there are 36 of these boxes, and only one of them has a 2 in it. So that's kind of how we get these. We're not going to do any sort of multiplication like this. We're going to just look at this chart and we'll add up the amount of whatever number we're looking for. So let's say, what is the probability of rolling a 7 after adding the 2 dice together? Well, let's look at how many of these boxes have a 7 in them. There's 1, 2, 3, 4, 5, 6. So the probability of rolling a 7 is going to be 6 out of 36. And yes, you can reduce that if you'd like. I'm not going to, just for the simplicity of seeing that there are 36 options and 6 of them work for this. How about the probability of rolling a 4 after adding the 2 dice together? Well, we have 1, 2, 3 that work for the 4. So it'll be 3 out of 36. And finally, what is the probability of not rolling an 11 after adding the 2 dice together? Well, this one, it might be easier just to see how many you have that would make 11. We have 1, 2 that make 11. And so we're going to take 36 and we'll subtract 2. And that'll get us everything that is not 11. So this ends up being 34 out of 36. And we'll notice in this case, we used the same property that we used way back in the other section to figure this out. We said, well, not 11 is everything else that's remaining. So if we figure out what 11 is and subtract it from the total, then we're going to find out what's remaining. And that is the 34 here. So that's basically all that property does, and it works really well. And so this is the sum of 2 dice chart. You may, in your classes, you might have to like calculate the probabilities for each of these. And it'll be pretty fun, actually. I like filling these out, but I'm unique in that sense. But yeah, it's cool to see how you can roll a 1 and then a 2 and get 3, but you can also roll a 2 and then a 1 and also get 3. And so that's just kind of the interesting part of it. And that's why it's so difficult to get a 12, and that's so difficult to get a 2 when you roll the 2 dice. So that's why like snake eyes is so unique when you roll the dice, and that's why people might like, whoa, you got so lucky when you did that, because you really did. If you get a 2 or a 12, you got really lucky. So yeah, that's all there is for the dice, and there will be something on the formative assessment, but it won't be with the 36 options. It'll be more of what we did here with the 6-sided die. So important things to remember. Well, the chances of something happening and the same something not happening add to 1. So that's what we went over using this example here, the green. And so just remember that the chances of one thing happening and the chances of that thing not happening always add to be 1. And then number 2, when you reduce fractions, that does not change the probability. That is true. And we saw that in one of the first examples way back with the spinner. Number 3, be sure to find the total amounts of events or objects as well as the chance of something happening to make your probability. And so what that means is you want to find the total, and that is the denominator of the fraction, and then your chance of that thing happening would be the numerator of the fraction. And then number 4, something is said to be more likely if its probability is closer to 1 than 0. If you are comparing two events, the one whose probability is closer to 1 is more likely. So, for example, let's say we're comparing the 7 and the 4. We want to find out which one is more likely. Well, 6 out of 36 and 3 out of 36 are not close to 1. If you want to check that, all you have to do is do like 6 divided by 36 or 3 divided by 36, and that will give you a decimal answer, and that will show you how close it is to 0. In this case, neither of them are really close. However, we can still decide which one is more likely. So we can say, well, the one that's closer to 1 is the more likely outcome. 6 out of 36 is closer to 1 than 3 out of 36. So I'd be tempted to say, well, it's more likely that I'm going to roll a 7 than a 4. And so that's pretty much all there is to this point here. The larger the amount is in your probability, and you can check that using decimals, the more likely it is. It'll be close to 1, maybe actually 1, but it won't exceed 1. That's impossible to do with probability. So yeah, I hope you enjoyed the video and that you learned a little something about probability. There is a formative assessment that you can take, and the link is in the description. And at the end of the formative assessment, there is a code you can enter for a virtual visitor badge. So I encourage you to take the formative assessment. Thank you so much for watching, and enjoy the rest of your day.